Welcome back to Further Solutions Academy. Further Solutions Academy. I encourage us more to share our video and subscribe if you have not subscribed before. On this video, I'll be working on indices in algebraic term and algebraic power. That is what I'm going to be working on this video. By the end of this video, you will understand how to handle or solve problems on these so-called indices in algebraic term or algebraic power. Now look at this particular question. It was posted on our page, and there are many of them. The video before now we have been on them, and also more are still here. How do I solve this? Let's try to solve it together. Now this times this, I will have 2 raised to power 6 dot 3 raised to power 6 divided by 6 raised to power. I can turn my 6 to what? 2 multiplied by 3 bracket of 6. Now, what I want you to understand is that I can turn this to 2 multiplied by 3 bracket of 6, which divided by what? 2 multiplied by 3 bracket of what? 6, which I can also turn into what? 6 bracket of 6 minus 6x. Can you see? I'm just talking about the power law, which I will be having 6 raised to power 0 and equals to what? 1. Because any number raised to power 0 equals to 1. That is why your answer is what? Is 1. The answer is 1. Now, look at this particular one. If I have s raised to power 3 all over s, bracket of, now why are we putting brackets here? Just to show that the roots stop here, and have this now equals to this and this. Find the value, find n raised to power n. Now this is a bit technical. Now what I just need to do, I can turn x 3 all over 4 bracket of y all over x 1 all over 2 y and 5 all over 8, which I have m and y raised to power n. Now since I have this, I can now say that what? S raised to power 3 all over 4, and I'll be having y 1 all over 2, x 1 all over 2, and y 5 all over 8, and equals to m yn. Now, can you see what I've just did now? I split this over them, over themselves, over s and y, which this and this, I can see that x raised to power 3 all over 4 minus 1 all over 2 dot y 1 all over 2 plus 5 all over 8 equals to x and y. Now, this will be 4, the LCM is 4, that will be 4, 3 minus 2, which is I'll be having s raised to power 3 minus 2, which is going to be, it will be 1 all over 4, yes. What am I doing? 3 all over 4 minus 1 all over 2, the LCM is 4, which is going to be 3 minus what? 2, which is going to be what? 1 all over 4. Now, also, I have this, which is going to be 1 all over 2 plus 5 all over 8. SM becomes 8, which is 4 plus 5, which I'll be having 9 all over 8. Please take note of that, just for those dots. Y raised to power 9 all over 8 equals to xm. Now, we need to compare here. What I just need to know here is that it means this equals to this. It means my n equals to 1 all over 4. And my n, this equals to this. It means my n equals to all over 8. That is by comparison. Now, since I have that, and the question is asking for n, m, which I'll be having, what is my n? 9 all over 8 bracket of 1 all over 4. That is what the question is asking for. Now, I can turn this to I can turn this to, normally, I can say that 9, 1 all over 4, and 8, 1 all over 4. I splitted it. Now, which I can also say that what? 3 raised to power 2, which is my 9, bracket of 1 all over 4. I can also say that what? 2 raised to power 3, bracket of 1 all over 4. Now, which I can now say here 1, here 2. Now, it means I'll be having 3 raised to power 1 all over 2 divided by 2 raised to power 3 all over 4. I can as well write this as I can say that 3 raised to power 1 all over 2 multiplied by 2 raised to power I have 3 all over 4, which I can also as well as root of 3 and also 4 root of 2 bracket of 3. Anyhow you want to do it, that is what you need to do there. Now, before I end this video, I have another question here that it will really help us to handle some things. I want to evaluate this particular problem, and 3 dot 2 raised to power 2n minus 2 and 3n minus 2 dot 3 raised to power n minus 2 divided by 3 and dot 4 raised to power n plus 3 minus 2 raised to power 2n. Now, let's try to work on this particular problem. It looks complex, but somebody sent it to me, which I just... Okay, let's try to work on it and see how it will be solved. But it's a very simple one. Whenever I have something like this, I can turn this to 2 raised to power 2n minus 3 raised to power 1 dot 2 raised to power 2n dot 2 raised to power minus 2. Now, I think I can bring out like this and have 3 raised to power n minus 2 raised to power 1, 3 raised to power n dot 3 raised to power. I also close another bracket, all divided by, and this can be 3 raised to power n dot 3 raised to power minus 4, and also 4, which I can turn into 2 raised to power 2n dot 2 raised to power 6 minus 2 raised to power 2n. Now, with what is here, look at me. I've tried to expand the whole system. Now, this I can bring it out, which I'll be having 1 minus 3 dot what? 2 raised to power minus 2. And the second one, and also I can say something, 3n and 1 minus 2 dot 3 raised to power minus 2. Now, divided by, I have 3 raised to power n, 3 raised to power minus 4, and this also will be 2 raised to power 2n, bracket of 2 raised to power 6 minus 1. Now, I think I've done a very nice job by saying that this will cancel this, which you can see that, and this will also cancel this. By so doing that, I've solved my problem by saying that 1 minus 3 all over 4, which it will go down. By now you should understand that, and this also will be 1 minus 2 all over 9 divided by, this remain 1 all over 81, which is that, and 30, which is going to be 32. It should be 64 minus 1, that will be 63. Let me just use the word minus. I know that 3 will go there. 3 here is 27, and also 9 goes. 9 here, 9 in 63 is to be 7, No, it will be 7. Yes, 9 is that. It will be 7. Now, and also, okay, 63 divided by 9. Now 7. Now I can see that 9 here is 7. 9 here is 9. Now I can also say that I think this minus that will be 4 minus that 1. I'll be having 4 minus that will be 1 all over 4 bracket of this also 9, that will be 7 all over 9 divided by that will be 7 all over 9. Now, which I can also write this as well as 1 all over 4 multiplied by 7 all over 9 multiplied by 9 all over 7. I think I change the division to minus. This will cancel this, this will cancel this. My answer remains 1 all over 4, which I can also write it as 2 raised to power minus 2. That is my answer. I can write it like that. Now, by so doing this, I think you are okay with algebraic form of indices. In the next video, I'll be working on equation parts of indices, which is it will be very nice for you. I'll be moving it on cases, normal equation, which is a linear equation, quadratic equation, and even simultaneous form of it. Don't forget to share our video, subscribe if you have not subscribed before, and if you need our attention, you can call us or you WhatsApp us. Once again, thanks for watching.